So the aim of development economics in a nutshell is to understand the poverty of individuals and countries. It can be easily said So the aim of development economics in a nutshell is to understand poverty, both at the individual and at the country level. Now, putting quite simply, poverty is caused by individuals being engaged in jobs that are bad, meaning that they have low productivity and low income. At the country level, similarly, poverty is due to low productivity. However, saying that is a bit like saying that the person who won the 100 meters at the Olympics won it because he was running faster than anybody else. It is quite trivial to say that somebody is poor because his income is low. We need to understand why such things happen. Now, these lectures will focus on the allocation of people with different talents to jobs, and how the availability of good jobs, the organization of labor, and productivity itself depend fundamentally on the allocation of talent. Let me start with a little puzzle. This is the first thing that I thought, at least that I can remember, as having a thought with economic content. Now let me zoom in here. This is Italy. The regions with the lighter blue have GDP between 15,000 and 19,000 euros. Those with the darkest blue have GDP of around 50,000 euros and above. Now, when I was 17, I moved from, let me show you, from here, Sicily, I went to study in Bocconi in Milan. That was probably the best thing that ever happened to me. But I was very puzzled when I went there because, see, this can be quite offensive for my my fellow Northern Italians. People in Milan, there's no simple way to put it, they weren't quite as smart as people in Sicily. To be precise, the average person in the street, the average fishmonger or cab driver that you met, they weren't quite as smart. And so I kept thinking, how can it be that Sicily is 5 times poorer than this place where everybody is actually so much smarter? Well, it took me a while to understand that was precisely the problem. That wasn't a puzzle. The problem was that everybody on the street was smarter, whereas in Milan, the smart people were in offices, were in hospitals, were in courts of law, were designing bridges. They weren't selling fish on the street. Now, it turns out that is quite an empirical regularity. So, in these lectures, I'll try to understand why. I will document differences in the organization of labor along the development path. We'll see that there is a progression from micro-enterprises to large multi-sector organizations. In the poorest countries in the world, we'll see everybody self-employed. Actually, starting from the simplest economy, the basic form of organization is the family. And of course, with the process of development, this changes, and the most successful firms start hiring workers, and those who are least prone to being entrepreneurs become wage workers, until we get to the shape of the economy today, which is dominated by large firms. At each stage, I will document how this organization of labor changes by the wealth of the people within the country, as well as their gender. And fundamentally, I will provide evidence from micro-studies on the various market frictions that put obstacles along the path, thus leading to multiple equilibria, poverty traps, and fundamentally misallocation. When I teach my students at the LSE, I always tell them to ask me, why does this matter? I always ask this to myself. Why should we know the answer to this question? Well, I think that the answer to this question is quite fundamental for the design of policies. Most policies focus on removing constraints to increase productivity of existing units. So there are a lot of policies in development that try to improve the productivity of existing firms. They give them grants, business training, microfinance, money to hire more workers. Or even within organizations, there is a lot of effort put into trying to improve the productivity of the existing workers. So by monitoring, by giving them autonomy, by giving them incentives, performance pay, and so on and so forth. Now, this kind of implicitly assumes that talent is properly allocated. That is, that the people who are working for the organization are the right people, and that the people who are running firms are the right people to run firms. Otherwise, if that's not the case, then trying to keep alive firms that shouldn't exist is probably counterproductive. At best, ineffective, at worst, counterproductive. If talent is misallocated, one of policies that improve the allocation have actually the potential to change the equilibrium, which is a much bigger change, is a change on the extensive margin, at a fraction of the cost. So we'll see many examples of policies which are quite cheap relative to the returns that they have. And the returns that they have entirely depend on the fact that they shift people from one job to another. Unfortunately, the timing of these policies, that is the fact that they have large upfront cost and larger benefits, but that materialize over many years, this timing is not exactly the most popular with elected officers that want results quickly, which they can claim that was thanks to them that the benefit materialized. So theoretically, there are two main reasons that underpin the existence of multiple equilibria. The first is whether access to jobs is driven by factors that are orthogonal to talent. The most common and the one that gets a lot of weight in the literature, and rightly so, is wealth. So there's a famous Banerjee-Newman paper in 1992 called A Paper on Occupational Choice, which shows how the distribution of wealth shapes the organization of labor, which is the number of firms, the number of people who are entrepreneurs, the number of people who are self-employed, and the number of people who are salaried workers. This in turn shapes aggregate income and future inequality. So, according to that framework, the economy can end up in several equilibrium. If it starts very poor with everybody equally poor, it might get stuck in an equilibrium where everybody is self-employed. If there is some inequality and the person who can start the firm is sufficiently talented, the economy might move to the good equilibrium where talented entrepreneurs run firms and hire workers. And because these are very productive, wages are high and everybody's happier. The fundamental intuition behind many of these models, at least the way I see them, is that it's not so much that some people are better than others in everything, but rather that people have specific talents. So somebody who's very good at engineering will probably be not so good at accounting, and somebody who's good at accounting will not be probably the best negotiator. So if you imagine a world in which everybody runs their own little business, each person has to do the accounting, the negotiation, the engineering. If you run a bigger business, people can specialize in what they can do best. A more sophisticated version of this story is the one that goes, the O-ring production function in the paper by Michael Kremer in 1994, where there is a strong complementarity between the output produced by one worker and the output produced by his co-workers. And it is this complementarity that generates the market failure, because if people are not allocated to the people with the highest productivity, with the productivity most similar to theirs, then there is misallocation and output is not quite as high as it could possibly be. Now, most of the evidence that I will show you today will relate to the first, will provide support for the first cause of multiple equilibria, that is inequality, both in wealth and gender, shapes the allocation of talent. At the end, the very last lecture, I will discuss some work in progress where we try to estimate the matching between workers with different skills and jobs where those skills are more important, and get closer to the production function complementarities story. Griliches made very important contributions in the economics of productivity, understanding productivity differentials. And I think the approach with complementarities is the one that's closest to his intuition that we need to have some source of economies of scale to explain the wide difference in productivity. My understanding of Griliches' work is that he pursued this idea of economies of scale, but then thought that quantitatively he couldn't quite explain the big gaps. But perhaps the Kremer model actually does add that extra ingredient that we need for the increasing returns to scale due to complementarities to be big enough, because in the Griliches models we were focusing mostly on technology and capital, whereas here the source of complementarities come from the assortative matching of people with similar skills. So once we put people back in organizations, once we put people in the production function, it might be actually possible to generate increasing returns to scale which are strong enough to explain the multiple equilibria that we see in the world. So let me start with a very simple question of why do people stay poor? This is based on a recent paper of mine with Claire, Robin, Matresh and Anton, and it's also based on an earlier paper called Labor Markets and Poverty in Village Economies that was co-authored with a subset of these authors and also Munshi Sulaiman, Imran Rasool and Selim Guleshi. So the basic question that we ask in this paper is whether people stay poor because they're only able to do bad jobs, or whether they do bad jobs because they're poor. In other words, this is a question that asks whether there are poverty traps. That is, whether poverty begets poverty. The idea of poverty traps has a very long history both in macro and micro development theory. There is some empirical evidence that uses structural approaches or micro studies with observational data. And there are some recent field experiments that relate to big push approaches. Now, testing directly for poverty traps is quite tricky because observationally they are equivalent to productivity differences. That is, assume that you see two people or two countries, one at a high equilibrium here and one at a low equilibrium there. If the only thing that you see are the two dots, you cannot tell whether this is due to productivity differences, that is, one person being on a low production function and the other person being on a high production function, that is, this one. And this one. Sorry, my drawing is not my biggest skill. Or alternative explanation, they are both facing the same production function, which has this S shape here. And one had the good fortune of being born past this unstable steady state here, and therefore ends up in the high equilibrium, whereas the other one was born poor and hence converges to the low equilibrium over here. Okay, so poverty traps, activity differences give the same equilibrium, the same observational equivalent differences in equilibria. However, they produce a different transition equation, and this is what we will use as a test. We will use the RCT of a large asset transfer program in Bangladesh and trace effects over 11 years to test directly for a poverty trap. And then we will estimate a structural model of occupational choice to back out the implied misallocation. Let me tell you briefly about the setting. Our study site is 1,300 villages in northern Bangladesh, and we have data on 23,000 households that belong to all the wealth classes. We collect a reasonably long panel over 11 years. So in 2007, we do a census of 100,000 households, which will form our sampling frame. And then in 2007, we ran a baseline survey. Then the targeting the ultra poor program is implemented in 50% of randomly selected villages. We have 2 follow-ups in 2009 and 2011, and this forms the core of the first paper, the labor market paper, which evaluates the program. We then follow people again in 2014 and 2018, and we will use the responses to the program between 2007 and 2011 to measure the existence of poverty traps, and then we will follow people over here to see whether the people which we identify being above the trap indeed do better than those we think are below. So if we look at the data, there's 3 things that emerge from these villages. The first is that if nothing else changes, the poor stay poor. We look at control villages and we see that only 3% of households that were poor at baseline move from poverty and reach the medium middle class assets. The second thing is that there is a precise hierarchy of jobs which is correlated with the poverty as seen by the community. And in particular, there is a clear segmentation whereby the poor do only casual labor in either agriculture or domestic service, and the rich, so to speak, are self-employed in livestock rearing and land cultivation. Now, better jobs require productive assets, and productive assets, which is livestock and land, is really what sets apart the rich and the poor. The rich, that is the richer people in the village, have 94 times as much wealth as the poor in productive assets. And richer households own more expensive and indivisible assets. So it's not the case that poor households own 1 chicken and richer households own 1,000 chickens. Rather, poor households own a chicken and richer households own land and livestock. Now, the first telling sign of the existence of a poverty trap is a bimodality in the distribution of productive assets. This suggests, but doesn't prove, that there can be 2 equilibria, one high at log 6 and one low, close to 0. The red lines are treatment villages and the blue lines are control villages. And this is the baseline distribution. You can see that it's almost identical. Now, here is a test. We use the BRAC targeting the ultra-poor program. This was randomly allocated across areas. Beneficiaries were the poorest women in these villages. The program transferred a large asset, which is a cow most of the times, and training on how to take care of it. The value of the asset is 1 year of per capita expenditure. At the time, this was 5 times the typical microloan, just to give you an idea comparing it to other programs. Now, entirely by luck, the program moves the poorest from the low mode to the lowest density area. And the reason why this is lucky is that if there is an unstable steady state, by definition, nobody will be around it. So if there is an unstable steady state, it will have to be somewhere around here. Notice that shocks of these magnitudes are very rare. So this is the amount, the average transfer, and this is the distribution of shocks received by control households between 2007 and 2009. And you see that there is less than 6% of households that receive shocks of that magnitude. So this is not something that we would observe normally in the data. Now, our test is based on the intuition that poverty traps and differential productivity, that is the two stories, the production function that looks like an S shape and the production function that looks like that, and there is 2 of them, they look equivalent in steady state because they both give you 2 steady states, one high and one low. But they produce very different transition equations. One will look like this and the other one will look like that. And a necessary condition for poverty traps is that the transition equation, that is the equation that links capital in 2011 in this case to capital in 2007, is not concave. So the way we can test this is by using the fact that beneficiaries differ very slightly in baseline assets. If you remember that by model distribution, there was a mode at close to 0, but it wasn't a single point. So we use a variation in asset which is small relative to the size of the transfer, but that should be enough to throw some people to the right of the unstable steady state and to the left if such unstable steady state exists. So what do we find? Well, the test consists in measuring whether the transition equation, that is the link between productive assets in 2007 and productive assets in 2011, looks like a concave production function or like this. The suspense is kind of ruined here because you can see already that it looks pretty much like an S shape. And there is an unstable steady state here, and this corresponds exactly to the minimum point of the distribution, the lowest density point. So how do we know that K hat is unstable? Well, we can see that below K hat people lose capital and above K hat they gain it. Now, our identification is based on differences in initial assets that are extremely small relative to the transfer, but is not randomized. Now, creating random variation in initial assets, which is sufficient to estimate the entire transition equation, is quite challenging because we have to populate. If we don't know where the unstable steady state is, we have to populate the entire x-axis with different treatments. And given that the treatment is at the village level, we would need very many villages. And the reason we need villages is that individual randomization of transfer values first is likely to violate the stable unit treatment assumption, because people will react to receiving the highest or the lowest just because it's relative rankings. And second, it will raise, more importantly, very serious ethical concerns. So identification here is based on differences which are very small but not randomized. So what we can do is to provide support, evidence in support of identifying assumptions. The first is that the K0, that is the initial capital, is not correlated with shocks to the change in capital. Now, given the placement is randomized, we can use the control villages to account for shocks. If we estimate the transition equation in control villages, that's what we get. This is a concave transition equation, and there is a unique stable. If you remember, the bimodal distribution corresponds to the lowest mode. Equilibrium, here is the regression equivalent. If we look at above K in control, there is no difference. If you do the diff, which is what this column 5 does, there is no difference either. We can also look at the possibility that there are endogenous program responses. Of course, we cannot use control villages for this because the program is not implemented in control villages. But what about the possibility that K0 is correlated with traits that determine the response to the program? Well, what we can do is residualize K on a large vector of individual traits, or use different sources of variation to compare those with the same K0. We do both things in the paper. I think in the interest of your patience listening to me in a recording, I will skip through them. I just show you the conditional transition equation. This gets a lot noisier because these are residuals, but you get exactly the same pattern. Now, what is the story behind the transition equation? Well, the transition equation links assets across time periods. So it tells us really the shape of the underlying production function. The fact that the shape is S indicates that there are increasing returns to scale when the level of assets is low. That is, there is a minimum viable scale of operations. Now, people with more assets at baseline are more likely to meet that. The threshold, however, also depends on the rate at which people can transform assets today into assets tomorrow. So this is their saving rate, S, as well as their ability to generate income for a given level of access. So what we do is that we use proxies of both A and S to shed light on the mechanism and to provide identification that does not depend on K0. Now, we proxy A by using earnings potential by village. Let me explain you how we do this. We basically, because we have other households in the village that are engaged in livestock rearing, we take the median earnings from livestock and we split villages into those where earnings are above the median and those where earnings are below the median. Now, earnings from livestock largely depends on the vicinity of a market. Okay? This, of course, is correlated with other things, but for the purpose of our test, it doesn't matter. What matters is that we see that the threshold is lower where the earnings are higher, which makes sense because if you get a cow and the cow yields 10 a year, you need to have more assets for it to be sustainable relative to the case where you get a cow that yields 100 a year because you're closer to the market. And this is what we see here. There are two thresholds. This is for the below median villages, and that's for above the median villages, which is much lower. So now what we can do is to compare people with the same amount of capital, So same K0, say 2.3, and we compare the person with the same 2.3, so the same unobservable correlated with K0, and we see this person is above this low threshold and below this one. Okay, so controlling for is K0, we can see whether he escapes poverty or she escapes poverty if she happens to be in a village where the threshold is 2.2 and does not escape if she happens to be in a village where the threshold is 2.4. So instead of using K0 as a measure of variation, we use the threshold. We can do the same with the savings rate, the same with health. Interestingly, anxiety is one that creates the biggest difference in thresholds. Education, and we can basically use this variation to identify the trap while controlling for the level of K0 at baseline. Okay? So actually this is not the level, these are actually fixed effect for each K0. And you see that it doesn't quite matter which of these heterogeneity sources we use. We always see that you need to be above your relevant threshold to escape the poverty trap. Okay? Interestingly, the effect of being above K hat does not depend on whether we control for fixed effects or not, which suggests that the threshold itself is not correlated with K0, which was our concern to start with. And then the second thing is that being above KL doesn't matter, because if you're in a village where the true threshold is K hat, you need to be above K hat to escape. Now we have a look at the long run, because poverty traps are such. If the difference which is created by the shock will determine differences in the long run. So these are a series of differences between people above and below the trap, the threshold, and before and after the transfer in different years. So the first one is difference in productive assets. We see that this grows over time. So this is the difference that we identified earlier. It stays stable 3 years later, and it shoots up 7 years after. This is actually driven, interestingly, by land. There's no acquisition of land for the first 3 periods, but after 7 years, some people manage to acquire land, which is, up until to that point, only owned by the richest households. The gap in consumption also increases over time, and interestingly is initially negative for those who are above the threshold, which suggests that they were saving to buy more assets later. This should cast a word of warning in using consumption to evaluate the effectiveness of poverty reduction interventions, especially in the short run when people haven't reached the new equilibrium. If we did use consumption as our metrics after 4 years and compare people above and below the poverty threshold, we would find exactly the opposite. That is, we would find the people above the threshold to be poorer by this measure than people below. So it's important to always remember that consumption is a good metric in steady state. There is an average gap in hours worked. It increases, so after 4 years, and it stays stable thereafter. Now, over 11 years, there is also life cycle savings that affect asset stocks. And what we see is that the asset dynamics reflect both the convergence to steady state and aging. Below the threshold, they go in exactly the same direction, but above the threshold, they go in opposite direction. So if we look at younger beneficiaries who are not still hitting the life cycle, the accumulation, we see that actually those who are above the threshold are 20 percentage points more likely to have accumulated more assets by year 11. And this basically splitting by percentiles. Now, we also estimate a structural model which allows us to quantify the benefits of this program, the benefits of reducing misallocation, and to do policy counterfactuals. So the steps are as follows. We first develop a very simple model of individual occupational choice. We calibrate individuals' productivity and these utility parameters from baseline and year 2 data. Now, this data has a very unique feature, which is that we observe two forced choices. At T0, the treated, by definition, can only do wage labor. Okay? Whereas at T2, by condition of the program, they must do livestock. Okay? So the conditions of the program are such that if they take the cow, they have to try for 2 years. After 2 years, if it doesn't work out, they can sell it. But for the first 2 years, they have to try. So normally, it's very difficult to estimate productivity because we only observe people doing the job that they can do best. Okay? But in our case, in the first period, they are constrained by their own poverty in doing wage labor, and in the second period, they're constrained by the program. So we estimate productivity using year 0 and year 2 data, and then we evaluate the model using data from year 4, 7, and 11. What the model does is to estimate each individual's optimal steady state and quantify the misallocation. So these are tests of the model after 4, 7, and 11 years. Okay? So this is hours in livestock rearing, the first row here, and this is year 4, year 7, that's an ugly 7, and year 11. Okay? And on the horizontal axis, we have capital in the year before, the period before. And you see that the green is the predicted hours by the model, and the pink is the actual hours. And you see that there is a very close fit. And actually the fit gets better as people approach the steady state. And same thing for wage work below. Now, how do we estimate misallocation? Well, we look at the people at the upper mode, and we assume that the ultra poor have assets that are equal to the upper mode, and then we use the model to estimate optimal occupation. So the actual is the pink. We know that we observe them only doing wage labor. So this is payoff at the actual occupation. And this is payoff if they were to do the optimal allocation. So you see two things from here. The first is that nobody, for most people, is optimal to do livestock rearing. So the total value of misallocation sums up to $15 million per year. The total cost of transfers that is needed to bring everybody above the threshold is $1 million, but it's $1 million one-off. So this program is always been touted to be among the most expensive poverty reduction programs, and it's true, it's very expensive, but the benefits are way larger. Now, the model suggests that 96% of individuals are misallocated at baseline. The value of misallocation, as we've seen, is way higher than the cost of eliminating the traps. The interesting thing is to look at whether this is robust to General equilibrium price effects, because you have more people self-employed in cow rearing, so the price of milk will go down. Doubling of the wage rate, because now there is fewer people in wage labor, so the wage rate can go up, or making wage labor less painful. So each one of those in turn. So the main concern with these estimates is that the more people do livestock rearing, the lower the returns. A price drop through general equilibrium is the same as a drop in productivity. So we see that when prices fall by 50%, the number of people that optimally specialize in livestock falls by 20 percentage points, and the value of misallocation falls by 57%. So how big of a drop do you need to break even? You basically need prices to drop by 90%, which is, here, is to double the wage rate. Then the number of people that optimally specialize in livestock falls from 90 to 60, and the value of misallocation only falls by 8%. Why is that? Because the people who move when the wage goes up are those who have the lowest productivity in livestock rearing. So we don't lose much in terms of misallocation. Quite unlikely. An alternative policy intervention, very similar effect if we make wage labor less painful. So what are the implications for policy? Well, put simply, if people are extremely poor, you need an extreme intervention. This graph depicts the share of people that would be brought above our estimated poverty threshold for each level of transfer. In order to compare our program with other interventions, we express the value of transfer as a share of per capita consumption. The BRAC transfer is 80% of the average per capita consumption, and that's sufficient to lift 2/3 of people above the drop. Now, where are the other programs? Well, these are the different pilots of the UltraPool program. They're all over the place. This is the typical microloan at the time at $100 or even at $200. You see it's way too low to help these people jump. The microloan is enough for 20% of them. In conclusion, what this paper shows is that poor people are not unable to take on the more productive employment activities. They just lack the required capital. The existence of a poverty trap suggests that only transfers large enough will reduce poverty in a sustainable way in the long run. So this opens up a fork in the road. We really have two ways to go to reduce poverty. The first is the standard social assistance approach to prop up people's consumption. So we subsidize people's consumption so that although they are income poor, they are not consumption poor. That is a cheaper policy in the short run, but more expensive in the long run because it requires transfers every year. The alternative is a big push policy that taps into the talents of the poor and help them escape poverty for good. Of course, there will be people that will require propping of consumption on a regular basis, but those, at least in the poorest villages of the poorest region or one of the poorest countries in the world, are the minority. The final graph that I want to leave you with is something that shows that this problem is more general than our villages. These are distribution of wealth indexes based on agricultural assets from the DHS surveys in Bangladesh, which the distribution is as bimodal as it is in our villages, and in neighboring Asian countries. So that's Bangladesh, this is Pakistan over here, this is Afghanistan, if I can move it. This is Afghanistan, you see. This is Myanmar, and this is Nepal. They all look quite bimodal, so the problem might be more general than just Bangladesh. Now my plan for the 3 lectures is as follows. I will continue this lecture by discussing the first type of barriers to reaching the good equilibrium, that is the distribution of wealth in the economy. I will show how the poor are stuck in a trap and the policy implications for that. Then in lecture 2, I will review some new evidence on the organization of labor across countries, and I will in particular discuss the allocation of women's talents. Finally, in lecture 3, I will study the two-way relationship between development and organizations. That is, how organizations favor growth and how growth and development itself makes it easier for organizations to thrive.